Hi, everyone. I'm happy to meet everyone on our Blockchain Community Day conference. We've already had a few interesting presentations, and I want to say thank you to every speaker. And now we are moving to the next one, which is about Git Open Source Hodler. And I would like to greet and meet our outstanding presenters, Eugene Morozov and Mitja Goroshevsky. Hi, Eugene. Hi, Mitja. How are you?
Hi there.
Hello.
Great, thanks.
Fine, fine. And let me present a bit Eugene. He is a remarkable person. He is an investment banker, certified public accountant, C-level executive with 25 years of experience in finance and 20 years in real estate, president of MEM Consulting, ambassador of Everscale Network, and co-founder of Everscale Academy, Devodeo and Units member of DeFi Alliance. Hi,
Thank you,
Eugene.
Andrew. Thank you, Andrew, and hello, everyone. That was a long introduction indeed. Greetings from Western Hemisphere. I'm speaking to you from Playa del Carmen, Mexico at the moment. And I'm very honored to be a repeat speaker at your events. It's a great mechanism to share information, share technology, and exchange opinions with a very professional group of clients of yours and members. So thank you again for inviting. Indeed, I represent Everscale network, and it's a community that's built around the network, which has a very good number of successfully launched tools and mechanisms. What is Everscale? For those of you who are not too familiar, Everscale is a peer-to-peer multi-blockchain system with a native token called Ever. It stands out for unprecedented high throughput and low transaction costs. At the time performed recently by Mitja, who is also present here, I believe that 50,000 smart contracts executions per second has been demonstrated over open internet, not on the lab, which to our knowledge is the record at the moment. Everscale indeed has record speed, reliability, and a very thoughtful architecture. Smart contracts can perform operations on different nodes, which allows this blockchain to scale and increases the speed of smart contracts executions. Everscale is asynchronous. It's asynchronous blockchain, which is flexible in software development and very rich in languages. You can write smart contracts in C++, Solidity, Rust, and some other high-level programming languages for your projects. We have already implemented a number of tools such as wallets, bridges, decentralized bots and exchanges, as well as all kinds of non-fungible tokens. The subject of today's presentation is especially near and dear to my heart. Security and safety, in my opinion, is somewhere up there with the fundamental values such as democracy and free speech. So it is incredibly important to make sure that the clients are aware of the most recent advances to address what Warren Buffett, for example, calls the #1 problem with mankind, and says that cyber attacks are a bigger threat to humanity than nuclear weapons. Cybersecurity Ventures experts estimate global cybercrime costs to grow about 15% per year, reaching about $10 trillion annually by 2025, up from approximately $3 billion in 2015, so 10 years, double. This indeed represents the greatest transfer of economic wealth in history. it presents significant risks to innovation, to investment, and is exponentially larger than the damage inflicted on us from natural disasters, for example. And it is also more profitable than the global trade of all major illegal drugs combined, just to illustrate the size of the problem. Now, IBM just released a report in July on the cost of data breach and says that it's hit a historically high record during pandemic. Data breaches cost survey companies $4.24 million per incident, US dollars, that is, per incident on average, which again is the highest in a 17-year report history that IBM has been doing. IBM also says that adoption of artificial intelligence, hybrid clouds, and zero trust approach lowered data breach costs. The US government is very concerned about this situation, which is reflected in President Biden's Executive Order 14028, published last year, which essentially mandates that US government agencies improve their software supply chain security. So it is my honor today, therefore, to present one of the top experts on the subject and the chief architect of the multi-thread, multi-shard Everscale blockchain, and my friend, Mitja Goroshevsky. Mitja, please.
Oh, excuse me, let me interrupt you a bit. Thank you. Thank you very much for presenting Mitja. I forgot to note for our audience that they can ask questions in the left area to the video. So please don't be shy, put your questions. And Mitja, let me present you, let me introduce you.
Go ahead.
Eugene has already started and I will continue. So as Eugene has already mentioned, you are the chief architect of Everscale blockchain and you are Gosh founder, the product that we will be talking today about. Also, you have more than 25 years in communications and distributed computer software development. Moreover, in the past, you've co-founded Delta 3, Internet Tele, Popular Telephony, and Ton Labs, which is now Everix. It's most exciting about your experience for the majority of the audience, I believe. So can you please highlight the topic, give us a hint about what you're going to talk about? What is the product about?
Sure. Thanks, Andrew. Yeah.
Thank you.
Humbled. So we're going to talk about Gosh and what Eugene said about the security threats that we have. And it happens to be that software empowers many supply chains and secures many supply chains. You all know that, right? So the products we're buying in supermarket delivered there by some supply chain, and the supply chain is controlled and secured by some software. What we kind of didn't do is we didn't take care of the supply chain of our software itself. We have a supply chain, but we have not thought too much about its security. So we thought about that, and we said we can do something about that using blockchain because of the reasons that I will highlight. And we also thought that in order to secure the supply chain of the software itself, you need to start from the source code of the software. Of course, you can take some repository running on some server and start securing its delivery to the end user or to the application, but it will always be the case what happened before you started your delivery, what happened inside your repository, how you secure that. So we said that of course, if you talk about some chain and its security, you need to secure all of it from the very start of the coding and to the delivery of the software. So what we did, that we basically said, okay, let's put whole Git on chain. That's first. Let's just do the blockchain for Git. Of course, it's a challenge by itself because no current blockchain can actually handle that. So of course you can take like the pack file of a Git repository and just store it on some decentralized repository, kind of like IPFS, for example, interplanetary file system or something like that. But it won't enable you to build a supply chain. It will only just store this pack file, which you can retrieve, and that's the only thing you can do with that. Right? So we said we actually need to put all the Git objects on the blockchain, because if you put the object, then you can do something with this object, and we will demonstrate you what you can do with that. So we started this project called Git Open Source Hodler, and of course, the Hodler, it's an acronym for holding cryptocurrency. It was originally from holding Bitcoin, so that we're saying, so it's open source Git, and it's in a blockchain. And so what is Gosh? Gosh is, first of all, it's a special built blockchain just for storing Git. And it uses Everscale architecture. It not uses Everscale blockchain as it is. And I will touch upon why. But so it's a separate blockchain that we started based on Everscale architecture. And then we implementing Git as a smart contract. And then we taking that and building containers, like Docker containers from that Git, from that, from Gosh. So two things are happening. First of all, the developer signatures, which are embedded into the blockchain, because blockchain is based on cryptography. Everything is cryptographically signed and proved. So developer signatures are there, stored forever, and attached to every object that you have inside this Git. And then everything you do with these objects create an immutable artifact by itself, because it creates a transaction. And it also, you send message to create transaction. Both message and transaction is immutably written. So why do we need that? When you have, it's a complicated slide, but just briefly. So you have this right now, on the top of the screen, you have what you have right now. So you have centralized Git cloud, like GitHub, for example, which most of people use, or GitLab, doesn't matter. Then you have your CI/CD, which is sometimes like, Jenkins, for example, you process some pipes that you did. Then you put it inside container, and then you orchestrate these containers and you put it somewhere, for example, in the cloud, or like delivery, whatever your delivery of your application is. In every 4 of these steps, you trust a lot of different things. You trust your login credentials, you trust the cloud API, you trust the source that's stored on the cloud, you trust the dependencies that you use in your project, then you trust the Jenkins server that runs your pipelines, you trust the enforcement of the rules of these pipelines, right? Then it's an eventually consistency that you trust. You trust, of course, upgrades and changes to this server software itself. Then you trust the container content. So when you build the container, you again trust the login credentials, then you trust your build scripts, then you trust your provider reputation, whatever it is, right? If you're running it somewhere, not on your own machine, right? And then here you go again with orchestration. It's a lot of points of trust. So it's very far from zero trust that Eugene mentioned. And it's very far from security. And we see every day, I think, we see just today was $160 million attack on some DeFi application. In August, it was a huge attack on GitHub with the social engineering and so on and so forth, which resulted in an attack on the Solana blockchain, and which stole a lot of user credentials, and the wallets was emptied, and so on and so forth. What Gosh is doing is we're trying to put a single trustless layer of truth, because blockchains are very good at that. actually. Like for already more than 10 years, we have blockchain which never been hacked as a blockchain. Not talking about applications, as this layer of trustless truth. It's very good at performing this. And so what it does trustless execution, because it's a trustless execution environment. When we talk about smart contracts, when you execute a program on a blockchain, you don't need to trust anyone. It has immutable execution results log, because the blockchain itself is an immutable log, of course, we call it immutable ledger. And it has also all the results of the transactions are there. So you can reconstruct the history from everything that your program did. And not only that, you also can put it in time. So you can maybe create an immutable log by creating some hash trees, but you cannot put it in the context of time. You never can prove when this log actually was executed, when the events in this log was executed, because it's just locally written. Okay, it has hashes, but when? And then you have an ability to enforce some rules using these two. So you can create a verifiable computational rules and enforce them. So when we talk about security, like securing the software supply chain, so we said many attacks like malicious scripts, dependencies, so on, and traditional centralized kits are not secure, not censorship resistant. And of course, we can talk about that also, because like just happened recently that some of the code was just, and it's actually happening a lot, just deleted from GitHub by some, I don't think it was even a decision of a court. It just GitHub decided, okay, let's delete this repository because we think it's bad. And then the more code you contribute, and that's where like the environment we live in, the more code we write, the less secure it becomes. We all know that paradigm, right? So how do we secure the software supply chain? First, it's a Git on chain. So every operation, commit, transaction, everything is written, trustless, traceable, transparent, and it's encrypted. Second of all, there is a blockchain, which is decentralized blockchain, which stores all that. And we can enforce some consensus rules to your repository. And we will show that every time you create repository on Ghost, you actually create a DAO, which is decentralized autonomous organization. So unlike on GitHub, for example, you don't have a single owner who can overwrite whatever, everything. And we saw attacks on the single owner using social attack just last month in August, when the repositories were created and some commits were pushed to repositories, which were malicious, and just with a one click of a button, one person decides, okay, this is good enough for my repository, and then a lot of bad things happening. So then you have this ability to create immutable triggers and actions. So signed artifacts. When, for example, you finished your pipeline building from the Gosh, you can then feed back a result of this execution to the blockchain and create this immutable artifact, which then can be verifiable and some action can be based on top of it. So you can create a script that will execute itself on the blockchain in a trustless environment and verify that you did everything correctly, for example. And then what we created is Docker Gosh tools on top of that. We will demonstrate that a little bit later. So yeah, so that creates a paradigm in which when a Git is on the blockchain, first of all, because, and I don't want to go deep into that, but because the blockchain execution environment is controlled, it uses a virtual machine, then it can be formally verified. Formal verification of software is a big topic. I don't want to go there because it will take too much time. But basically, you can create a specification, formal specification of what your program will about to do. And then you can actually prove mathematically that your program is indeed performing just what is written in this formal specification. So you can formally prove using using some special tools that your program is correct in comparison to your specifications. And Gosh itself, it's a first implementation of Git, which is formally verified. So there are like no bugs. I can say it's just a little bit simplification of that. Of course, there can be bugs which we didn't put in the specification, but if our specification is formal and correct, then the program is formal and correct. And formal verification is used by NASA, and it's used by some bullet trains and so on and so forth. So it's basically the best tool to secure any software. You cannot really secure any software because it depends on outside environment, or can depend on outside environment. So you cannot take just a bash script and formally verify it. But what you can is create a smart contract from the bash script and formally verify it. Okay. So the Gosh itself is a formally verified Git implementation. Then we put all this smart contracts and all your Git, basically your repository, on the Gosh blockchain, right? And the Gosh blockchain, Eugene a little bit tapped into that, but it's a never scale based. So it's a multi-threaded, multi-sharded blockchain with a throughput up to well, basically unlimited theoretically, and we can store everything on the blockchain. So we can store GitHub on the blockchain, basically. So that makes a repository censorship resistant because we can create DAO from this. And let me show you maybe just a second how the DAO will look like. So I have some repository here. This is my DAO. Okay, I don't have here the on this repository. I don't have DAO. Do we have, Andrew? Let me see. Okay, maybe here. But oh yeah, okay, here we have. But don't know. Yeah, there were no events. But if basically you take if you take a branch and you lock it here, like, of course, if it's unlocked branch, then you can just push anything you want into that. But if you lock it, then oops. Okay, I didn't create. I need, okay, everything that I do demands in the DAO demands voting. So if I lock the repository here, and I just don't have tokens right now into the balance of this voting power, but if I do, then we will all vote for the DAO to be for the branch to be locked. And if the branch locked, every merge into this branch will require the voting of the DAO, which prevents a lot of attacks on social engineering attacks, like what happened to GitHub last month, when just single person decided to do something. Also, what DAO enables you is for open source projects, because the DAO automatically, like, it manages repository by providing some tokens to its members, and then you can vote with these tokens on your repository. If there are decisions of repository, can be like adding new members to the repository, contributors, and so on and so forth. So you can take that token and monetize it if you feel like doing this. So that can provide a monetization tool to open source repositories just by being on Gosh. So then, okay, so you put all your repository on Gosh, and then you can, as I said, create immutable triggers and actions. And immutable triggers and actions is then used in your CI/CD. And Andrew Kurishkin, who is here, and CTO of Gosh, will actually demonstrate now, and I will give you, Andrew, we'll demonstrate how it works, basically.
Hello, yeah, I'm going to demonstrate that's pretty much working with Gosh as easy as working with just a regular Git. Let me share my screen. Okay. Can you see my screen?
Yeah, we do.
Okay, cool. And just let me take one repository. Oh, shit. Okay. It's a small repository just for demo purposes. And let's clone it. What's basically is going on here, we are using regular Git client that connects through our helper to, oh shit, it's, to the blockchain, and it downloads through the contracts, through the contract interfaces, pretty much the same thing as it would be in the Git cloud. All the files are downloaded. It's the same files as here, and we can modify files. Oh, yeah, I forgot one thing. Actually, to push files, you actually need to set up Git remote, and this is fine. Yes, I'm exposing my secret keys, my pub keys. They're for test purposes. I will change them later. Don't worry.
That's a reminder to yourself.
Yes, but no, this is specific repository for those purposes. It is okay. In okay situation. So this is what is need to be set up. So usually you put this in the Gosh config JSON. In my case, I have some environment settings that allow me to put it in different folder, but okay. It should be in here. Yes, pretty much the same pub key secrets. You can use underscore hash here. So this pretty much uses your user wallet to send all of these files, and uses this pub key for the Gosh for the Gosh repository itself to sign your changes, to sign your commits. For in this case, we are using mainnet, which is expected, and that's pretty much. I mean, that's pretty much simplest way of interacting with Git, I mean, with the client. Okay, and let's check.
By the way, this is what you see now is a Docker desktop extension of Gosh.
Yes,
we did.
I'm using Docker desktop extension.
Where one of the Gosh is one of the launch partners of Docker, of their product called Docker Extensions. If you didn't check it out. And one of the 15 extensions that originally were launched. One of them was Gosh. So you can just take the Docker desktop, install this extension, and have all the interface ready. Yep.
So my main thing is here that you can use this interface, of course, or you can go to the website to use this interface, but you don't need to. We have Git client, just regular Git client that you can use to do any changes, push, pretty much clone everything. And this is common workflow when you just download clone repository, do modifications, create pull requests, everything, and that doesn't use centralized repository anymore. It just goes to the cloud, to the Gosh blockchain, and it's replicated on all of the validators in the blockchain itself. So that's pretty much it. That's, I think, main important thing, that you can just, without changing your regular workflow, how you interact, how you do things, just switch from using centralized repositories to decentralized repositories. Okay.
Great. So would you show us some image of the like?
1 second.
Because in the Gosh, in the extension, there is a way also to like build and then verify the containers themselves, and that's part of course, the reason why we're doing all that is that you can take the container you built the container from Gosh using Docker tools, and the extension verifies that the container was indeed built from the Gosh, and that verifies that the security of Gosh itself and all the smart contracts that you built, all the if you build any tools that verification tools inside your workflow, then it just verifies that okay, the container is fine. That's it. And it means that during this delivery, there is no one who could actually go and insert malicious code or like did something with your scripts to insert something, right? Or to leak something, for example. Right? We had that security key. How many, like 4 days ago, 5 days ago, the whole environment of Uber was stolen, was exposed and stolen. How about that? Because someone just had inside the network, the Uber network, internal Uber network, had a script which had all the credentials in it, just like that. So talking about securing software supply chain, right? So when you build a container using Gosh tools, the build process will deploy smart contracts with all the like artifacts of your pipeline into the blockchain. So that will create an immutable log of that. And also that you can take them and use this by listening to this blockchain events. You can then take them to some other server, verify that indeed everything is correct. You can verify that it was done then it wasn't done, and then that it was signed by whoever it was need to be signed, and then that the hashes are matches between what you expected it to be and what you got inside your our tooling.
Yeah, but for this thing, I actually have a broken environment right now, and I just jumped to this presentation the last minute and replacing the person who was supposed to show this. That's unfortunate. I'm very sorry about that.
Okay. So, okay, you don't have containers to show. Okay, that's fine. But you can go and check it yourself if you want. It works. It has marketplace inside the Docker extension tools, and you just install Gosh, and that's it. So let me just share my screen again and just talk the last thing. So yeah. Okay. So basically that's what we spoke about. We have these tools that we built for you. Of course, it is still like the project is 6 months old. So yes, we have a lot of stuff to do, and we have some, obviously bugs and issues around tooling and things like that, where it's an active development. You can actually help us doing this in going to our repository and contributing to it as an open source. So again, we take container signature hash keys, we compare Gosh images with keys, with Docker containers, and and we all the time while we're doing that, we're creating those artifacts, feeding them back into the blockchain, which creates the immutable log. So yeah, we have currently like Gosh Web, which is a Gosh web interface, like what I just showed, app.gosh.sh, and you have Gosh Docker extension, which also has the web interface within it, but it also has the container verification stuff in it. And it's free. We don't charge anything. We might charge something but and I know there will be some questions related to that, how it's a blockchain and it's free. Well, yeah, it's blockchain and it's free. So it's free for open source projects, and exactly the same model as GitHub or GitLab, more or less the same. And except for we're not charging anything at the moment, and we don't know when we will start charging something. So right now it's just completely free, and we have an extensive roadmap of what we'll do. Some of which is already done, and some of which we are still planning to do. So again, as I said, we were one of the launch partners of the Docker extension, Docker desktop extensions, and over this 6 months, we got a lot of feedback from developers, and we're happy with that. And if you can provide us any feedback about anything and try it, we would be more than appreciating. And well, our users are whoever needs security, and I think that's just about everyone today. And of course, apart from that, any open source projects. So thank you for your time. Hope that was entertaining.
Thank you, Mitja. Thank you, Andrew, Eugene. It was very interesting. It's like, from my insight, it's like a new generation of version control system. Yeah.
It's the same version control system, the most popular one, the Git, but decentralized. Yes.
Yeah, it's a new step ahead. Okay. Let me search or find for any questions. So we have a few questions, and the one is from Anton Shi. How do you deal with the uploading and handling of large repositories?
Yeah, that's why this is the Everscale architecture was used, because it has this throughput which enables it. And how it's doing this is by basically parallelization. It's very parallelized. Actually, if you go and just do one commit with a file, it may be today still quite slow. I mean, you need to wait maybe half a minute for this file to appear. But more or less the same time will take you to upload 100 files, because the blockchain itself is asynchronous. It's multi-threaded and it's multi-sharded blockchain. So you can actually concurrently create a lot of operations. And because this in Git, all the projects are objects are, well, can be quite easily parallelized. There are some things, some operations that are required, like to prove that your commit is actually need to kind of collect all the proofs that you can actually commit. That might take time, but you're doing that after you uploaded everything. So bottom line, it works. Yes, we can store like huge repositories, and we are actually planning to push the repositories in just maybe next month, once the last release, what we're working on, is released. We want to push a lot of open source repositories like Linux and others that are widely used to Gosh, just to be there. And so you can build containers, like secure containers from these repositories, without you need to push all of that yourself.
Mitja, just a quick comment. When you say parallelized, you mean it runs concurrently? Yep. In parallel to one another. It just sounded like paralyzed to me. I just wanted
it's a parallelized computing operations. Yes,
it is parallelized upload for multiple files. It's pretty much the same thing, speed as you upload one file, and on top of that, we are actively working on improving performance even for a single file upload, so just to reduce number of steps done there.
Yes, and of course the Everscale itself, like the architecture, is constantly evolving, and the finality, what we call the time that takes one operation to finalize, the finality times will be reduced going forward dramatically also. So we expect that to happen.
Okay, thank you. That makes sense. And maybe from my side, a reasonable question after handling large repositories, and Anton, she also continues to ask this question, and it also arises from myself. So what's the speed of the blockchain? Is it fast enough for the end user to be comfortable? For example, as far as I know, any blockchain like Ethereum or Bitcoin, it takes time to sign every next block. So how do you deal with this problem?
It's because they have only one, basically like one chain of blocks. We don't have one chain of blocks. It's actually scales almost unlimitedly how many blocks in parallel you need to release. Of course, again, if you have an objects that are need to be performed one after another, then you cannot do much about that. But fortunately, in Git, you don't have such problem. You can actually like just deploy all these objects in parallel and then just verify that they are all okay. So in that respect, we can just spawn as many processes. Like think about process multi-threaded processor, and you can just spawn the threads, and we can spawn these threads almost unlimitedly. And that's why,
if I may, I'll quickly add to that, Mitja. Again, thanks to your architecture. Essentially, Everscale can reach any number of smart contract executions per second, as long as there are enough validators to confirm the block. So let's imagine hypothetically a use case which requires 1 million steps. It can be done by expanding the number of validators, and then the system will run the tasks parallel to each other, essentially achieving any throughput number. So to answer your question, that's how it's done, by running.
I'm just showing parallel. I'm just showing the explorer of the blockchain. Yeah, there are 4 threads right now running, but if it would be overloaded and the threads would not be enough to cope with all the load, they would just spawn themselves. They would just multiply here. You would see like this number growing very quickly, like to 256 or whatever threads if necessary. So like, and right now, like this number, average block time, will actually shrink tremendously to like 0.1 second and so on and so forth. So in parallel, again, each block would still require like 3 seconds to be validated by the thread, but the number of threads can grow and parallel execute this range of smart contracts in parallel.
Thank you. That sounds nice. The next question from Anton as well. How do you deal with the cost of transactions and commissions on the network? Is it free to use, Gosh?
Yeah.
It maybe will answer the question why the product is free right now.
Yes, exactly. No problem. And that is also answering the question why we didn't actually start the Gosh on Everscale blockchain actively. Well, because Everscale blockchain has the tokenomics of the blockchain, normal blockchain, which requires to pay transaction for every time. Right? And we said from the beginning that if we want Gosh to be successful, it needs to go like a normal app, because a developer that uses Git, GitHub, GitLab in open source, for example, environment, or just starting their small repo, they don't expect to pay for it. And of course, we need to accommodate that somehow. So we asked ourselves, can we do that? And the answer was, yeah, we can do that. So we created a special economics for the Gosh. And these economics enable us to actually take part of the smart contracts, not all of them, but just part of them, the basic smart contracts of Gosh, and say, that will be on us. Basically, that will be on the validators. The validators will perform, because the operation is actually, because it's scalable blockchain, the operation itself is not that costly. Like, you don't take the time, the second of a blockchain, and just, if you need a second of operations, it will be the second of the whole blockchain. So you need to pay for all of it. Right? In our case, it's second divided by the parallelization factor, whatever it is. And because we can slice it many times over, then we can slice the cost. The cost is very minimum for each operation. And therefore, some of them we can say, as AWS is saying, right? Start the server for free. The economics are the same. Why the economics of running a blockchain should be different than the economics of running a server farm? It's the same. It's not different. So if you just think about that from another perspective, you can say, okay, there are some things that blockchain need to pay for, but not everything. Like you can, this is just the cost of your operation, put it inside the cost of your operation. That, by the way, if the blockchain doesn't do anything, let's say there is no transaction, you still pay for running, like you still pay for electricity, for running the server. And of course, it's a proof of stake blockchain, by the way, which means there is no proof of work. It's a good for environment, but you're still running the servers. It doesn't matter. So, you know, you need to pay for them. So it's basically just free time. You already paid for it, and it's monthly payment. And it's just depreciation of the cost of your hardware. So that's why we just enabled that. Basically thought about that and say, from the beginning, we said, okay, we'll build a blockchain that can enable free tier.
Mm-hmm.
That's what we're doing.
That's nice, but let me ask from my side a question. Does these local tokens, your blockchain tokens, do they have real value? So
right now we're not thinking about value. It's not very important. Like, of course, it is quite easy to create value from the blockchain token. You just need a limited supply tokens which provide some value to someone, right? We think right now what we're interested in is running this thing and make it good for developers, and you know, and really showing that it works and it can secure something, right? So right now we're not releasing any tokens. But in the future, the tokenomics, yeah, of course, because we need to pay, validators need to pay their bills. So there is a cost to run the network. So yeah, in order to make that up for, we will release a token which is called Gosh, that will basically enable you to be a validator on the network and then pay you some fees. But I don't want to go into tokenomics, but yeah, there will be a token. It's just that you will not get as much from transactions as you would get if everything would be not free. And so some of that you will sustain as a cost of running the network. Some of these transactions, they will be free. That's all.
I see. And before our meeting and presentation, I've made a bit of research about Gosh. Am I correct that every like merge pull requests, they are tokenized as well? So developers put their own tokens to make commits or merges or pull requests?
No, not true. It's not. As I said, when you create a repository, your repository, you create your own token with this repository because you created your own DAO. Now, then you can do whatever you want with these tokens. You can give these tokens away for free to everyone who you want to manage your repository. And by managing repository, I mean voting on your commit. So it's not that you need some other token to vote for your commits. No, you have your own token of your repository. Give it to someone if you want him or her to vote for commits. So or merges into the locked branch.
So each repository has its own governance tokens, yeah?
Yep.
And
automatically.
And
so you create repository, you create the governance token. Exactly.
Oh, that's really revolutionary. I think it would be a use. It will be a use in the future. So now I got the idea.
Yeah? We hope to see all of you guys. Therefore, if you like the idea, we hope to see you very soon.
Few projects that already started to use it, and yeah, there are repositories have been created, and there are tokens governing them.
That's really exciting. And what customers already do you have? How many of them?
We don't have customers. We don't look at this like that. It's just a community. We just started. Basically, just a few months out. So yeah,
only a few months out. Yeah.
Yeah, as I said, the whole project is 6 months, and it took us, 3 months to build it. So we kind of 3 months. It was launched on May 10th, so it's like a little bit more than 4 months. So yeah, that we don't track. It's just a blockchain, and because it's free, we cannot really tell you how many of them. But there are some Web3 projects that we know of because we talk to that are going to use Gosh or already using Gosh for their decentralized projects. And if you think about that, for decentralized project to store their code on a centralized repository, it's kind of absurd. I think we very quickly, once we have that and everyone see that it actually works and you can use it as a decentralized Git, I don't think, like you would ask, as you ask today, Web3 developers, is your project decentralized? Then you would, next question you would ask, are you storing your code on decentralized Git? And because obviously it's part of the like decentralization of your code is part of the decentralization of your project. You cannot say, okay, our project is decentralized, but our code is completely centralized, managed by this guy. Then if what is your project then if not the code?
Yeah,
right.
That makes sense. Okay, I believe we've run out of the questions. As for now, let me check. Yeah. So thank you very much for your interesting presentation about your revolutionary project. Honestly,
thank you. Thank you
about
very much.
the new generation of VCS system. And thank you, Eugene. Thank you, Mitja, and all your team, including Andrew. It was very interesting to find out details about how it is working and how it is developed. And I would like to thank you to all our audience, to all who are watching us. And let me remind that we have NFT giveaway. The details you will be able to find in the email right after this event. And for now, bye-bye to everybody and move on to the next speaker. Thank you very much.
Thank you.
Right.
Great.
Thank you. Hope see you soon.